In the previous video, we built this cool electric motor from scratch, and we got some questions about how to create the custom ESC, how we did it. We can go into more details. So this is just going to be a quick video about the ESC. So this is an example of an electric speed controller you can buy off Amazon. This ESC needs a PWM signal, so a pulse width modulation signal, in order to drive the motor. What's easiest for me now is just to use the Raspberry Pi, do a simple program inside of Sketch that will create that PWM signal, and then once it's connected, I'll show you the code to drive this basic off-the-shelf ESC from Amazon. So our three phases are connected to the variable power supply. We have 9 volts, 2 amps to start. We're going to get the PWM signal out of digital input pin 9. So I just connected the Arduino to my MacBook, and we're inside Sketch here, and we have written just a basic script so we can send a signal to our Amazon ESC. So here is the setup, and it runs as soon as we connect the Arduino to the MacBook. The startup sequence will actually play from the motor. We will actually hear sounds, the vibrations, if the startup is correctly. Let's turn it on and let's hear the startup sequence. You could hear the startup sequence there. It has initialized correctly. If we go back here to the code, and this is our main loop, so now we want to start the motor, and we do that by sending it a value between 1000 and 2000. So I'll say 1400 to start. And now we can increase the speed to 600. We can increase the speed to 1800. And this will run for 10 seconds, and then we can send a stop signal by giving it the 1000 input, and this should stop the motor now. Perfect. So that is our Amazon electric speed controller that we bought directly from the shop, and this was the pretty straightforward code, the PWM signal that we're sending to it. Now, if we want to build our own custom ESC, we need all the same components. 3 phase outputs to control the motor. We'll need to supply power to the motor, and we'll need to give it input to say which phases to power and when and how fast, how slow, etc. So we need 3 P-type MOSFETs for high side switching, and we'll need 3 N-type MOSFETs for low side switching. For the high side MOSFETs, we have IRF 4905. And for the low side ones, we have IRF 520N. So 3 high side and 3 low side MOSFETs. Next is we'll need level shifters, 3 of them. Our 1K resistors, we'll need 3 of them. Our 10K resistors, we'll need 6 of these. And we'll also need one of those capacitors as well, just to protect some of the components. So let's assemble them all on a breadboard and see what that looks like. Okay, right here is our custom ESC assembled. P-type MOSFETs for high side switching and the N-type MOSFETs for low side switching. And we have the 3 different phases: green phase A, white phase B, yellow phase C. The variable power supply is supplying 9 volts at 2 amps to our breadboard. Our Arduino is also being powered from this. And then we have our digital output pins from the Arduino back into the breadboard. The P-type MOSFET, when it is on, it is going to send 9 volts to the phase A output wire. The source of the P-type MOSFET is connected to 9 volts, the 10K pull-up resistor that is also sending that 9 volts to the gate of the MOSFET. So the source is at 9 volts, the gate is at 9 volts, so it's currently off. In order to activate the MOSFET, we need to pull down the gate to 0 volts. So the source will be at 9, the gate will be at 0, and if that happens, then the P-type MOSFET will be activated, and then 9 volts will power the phase A wire. In order to do that, the Arduino is going to activate the digital pin 10, so we're sending 5 volts to our breadboard. The transistor will connect to the ground rail, and then it will try to pull down the M-type MOSFET to 0 volts. So then we'll have our difference between 0 volts and the 9 volts, and this will be activated, and the 9 volts will go through to the phase A wire. We have our big capacitor here just to catch any sort of errors. We have our 10K pull-up resistor, our P-type MOSFET, our level shifting transistor, our 1K resistor to protect the Arduino. So that's the high side switching. Basically the same for the low side switching, but this time we have the N-type MOSFET, and we have the pull down resistor, a 10K pull down resistor here. So when we get the signal from the Arduino, there is going to be a difference between the ground and the 5 volts from the Arduino now. So then the MOSFET will be activated, and when it's activated this time, it's going to connect the phase wire to ground. So high side to 9 volts, low side ground. We have our custom ESC connected to our different phases, connected to the variable power supply and our Arduino. So we have the Arduino code, which I've linked in the description, and we went through in the previous video. So check out the previous video if you want to see the details of that. But basically the code is we're going to send a signal to the motor saying which phases to drive and when. So then we'll go phases 1 to 6, and we should see the motor move snap to each position. And we'll do that 4 times to get a full 360 degrees. Go to phase 1 and you should see it snap. There you go. And then 2, 3, 4, 5, 6. And we should, so that's 1 electrical cycle. So we need 4 electrical cycles to get a full 360 degrees. So let's do the full 1, 2, 3, 4, 5, 6. And let's finish it 2, 5, 6. And last one, 1, 2, 4, 5, and 6. So we got a full 360 there. So our custom ESC is sending a signal to different phases of the motor at different times, and we can control every phase exactly as we have programmed in the code, which is great. So now we can spin it on a full loop continuously. S to spin and start. Here we go. And I can increase the speed. And now let's increase again. And again. So our custom ESC is running code that is an open loop. It doesn't know where it is, so once it gets out of sequence, it's lost essentially. So we have to go back to where the loop continues. So that's the disadvantage of the open loop. We can also possibly test out a closed loop system, improving our basic breadboard, adding some sensors to track the back EMF, similar to our Amazon ESC. So let me know in the comments if you want to see something like that.